Hello, my name is John Kozel. I'm president of SIMSITE Pump Company. Today's webinar will be on why SIMSITE pumps, impellers, and other pump upgrades are superior to all metallic products in corrosive applications. SIMSITE Pump is entering its 102nd year in business, and we manufacture structural graphite composite pumps, impellers and rings, and other pump upgrades, bearings, sleeves, which never corrode in seawater, brine, wastewater, sewage, chlorinated water, bromine, and they're excellent with many chemicals. Okay, if you have any questions at the end, please save your questions at the end, and you can hit the tab for questions, and I'll be happy to answer any questions you may have. Okay, let's get going here. Imagine a pump that would last indefinitely without the following problems. Imagine a pump that didn't have corrosion problems. It's huge. Corrosion is one of the largest problems that we see today. With the more and more pressure for lower priced items, the metallurgy has deteriorated over the years, and we see more and more corrosion problems. The warmer the seawater, the higher the corrosion rate. Corrosion is a huge problem, and it's growing. Cavitation, another huge problem that we see. Imagine a pump that didn't have cavitation. More and more pumps are not operating at the best efficiency point, and they're subject to cavitation and cavitation problems. Casting problems, and it's not just metal. If you see, here's a casting problem here. These two are molded composites, and you can see the deterioration occurring, breaking, that occurs with poor casting. No electrolysis. Electrolysis is another huge problem that we see. With pressure coming on for low price, a lot of customers are perhaps changing items such as going to duplex or super duplex. Not only are those items heavy, but they cause electrolysis for the rest of the pump casing. So the higher the nobility, and there's a bigger, it doesn't corrode, but the difference causes problems. And the weaker metal with the weaker nobility is going to be sacrificial, and it's going to corrode. You can see the wear on these casing bowls here. This is another huge problem that we see more and more of today. Performance deterioration. People forget about performance deterioration, but it's huge. If your units corrode, they cavitate, they erode, you have huge problems. This performance deterioration costs a tremendous amount of money, both in maintenance, repair, and energy costs. And energy costs are becoming a more and more significant part every single day. No erosion. Imagine a unit that didn't have erosion. Erosion is another problem we see. Sometimes it's combined with corrosion and cavitation, but still erosion is an issue. Sand, silt, all causing problems. Clogging. Clogging is also an issue. It can be easily fixed, but clogging is an issue. We see, especially in wastewater, a lot of problems with clogging. Imbalance. Overhung units, huge problem. They're heavy, they cause problems. It's a big issue. They're asking way too much for overhung units. And imbalance is one of the largest problems that we see today. It's not just mechanical imbalance, it's hydraulic imbalance, radial loading, all balance problems. Not operating at the best efficiency point. Probably this is the biggest problem that we see out there. Pump is supposed to operate at the best efficiency point, within a few percent of the best efficiency point. If you're operating back on the curve, you're in a high radial loading, pump is experiencing circulation, cavitation problems. Same thing if you're out on the curb. These are danger zones, high radial loading. On this graph here, I'm showing you want your pump to operate at the best efficiency point. If it's not, you're subject to this radial loading, vibration problems, and premature bearing, seal, and motor failure. It's a huge problem today. Lots of times customers come to me and they say they have a seal problem or bearing problem. No, they have a hydraulics problem because the pump is not operating at the best efficiency way, which can easily be changed when we upgrade to SIMSITE. Lightweight. Imagine if the pump was lightweight. If you didn't have an impeller running on your shaft, you'd never have any problems. Now, this same bronze impeller is 120 pounds. The same one in SIMSITE Structural Composite would be 20 pounds. It's a huge difference, 6 times. It's huge. And you can see, especially on overhung units, but on larger vertical pumps, you can see this particular impeller here, the wear in the casing from the pendulum effect, which we had discussed in another webinar. The shaft becomes and with the impeller on the bottom becomes a pendulum, and it wears against the casing, wears the bearings, causes huge problems. So if you can reduce weight, you not only reduce your startup load, but you reduce the pendulum effect and the shaft deflection. Coatings. People sometimes think they're doing a good thing for coatings. No, what you're doing is you're causing more problems. Most of the times the coatings to go in, you're closing your channels. You're closing your channels, you're moving the pump back on the performance curve. You're moving into high radial loading cavitation area. Look, all coatings come off. It's just a matter of time. They're a Band-Aid. You put a coating on. If you have high velocities, vortex, it's taking the coating right out. A water jet will cut right through steel, no problem at all. So people would say, oh, my coating will hold up. No, coating lasts temporarily, but where it comes off, you get holes. And then you get this concentrated holes can cause vortices, and it can cause cavitation, and it will cause holes in your unit like you see in here. Okay, what is the solution? The solution is to use SIMSITE Structural Composite Pumps, Impellers, Casing Rings, and other pump upgrades, which are lightweight. They're 100% machined. They're not cast or molded, and they don't corrode. They don't corrode. They don't support electrolysis. They don't go into an imbalance, and they're balanced both mechanically and hydraulically. And most importantly, they don't suffer from performance deterioration like metallic pumps do. The SIMSITE impellers are 85% less weight than bronze or stainless steel, duplex or super duplex. And the vane passageways are all machined on the inside as well as the outside. So you have perfect hydraulic balance, and you have mechanical balance because it's all machined from one center position. The SIMSITE composite pumps and impellers are designed and engineered to make the customer's operating point the best efficiency point, or the BEP. Many times when you're buying production units, most times, you put it in your system, it's not operating at the pump's best efficiency point. It's operating off. Sometimes it can be 10% off. It's huge. You want to, in order to get the pump to operate exactly at your operating point and make that the best efficiency point, it has to be machined. So when we machine it, we're machining it exactly for that operating point. The use of SIMSITE technology allows pumps to operate substantially longer without premature failure of the bearings, rings, bushings, sleeves, mechanical seals, and motors. Because SIMSITE composite impellers eliminate and pumps eliminate corrosion, electrolysis, and cavitation problems, they enable the pumps to operate much longer at a much higher efficiency. Now, I go over some of the advantages of the pumps. They're machined from solid blocks of the patented SIMSITE composite, which is very important because we're machining exactly for your customer's operating point. It eliminates all corrosion problems, all cavitation problems, because we're designing specifically for the best efficiency point. Your cavitation problems are eliminated. It eliminates electrolysis because the SIMSITE composite is inert. In other words, it doesn't support galvanic corrosion. It doesn't have performance deterioration, so you don't have performance problems. It eliminates all your balance problems, mechanical, hydraulic, and radial. Now, it's lightweight, which is important, especially weight has become a big factor today. And as a result of being engineered for best efficiency point, repair and maintenance expenses are minimized. Your pump operates at a higher efficiency because it's designed for the best efficiency point, and it doesn't deteriorate. When you take a metallic pump and you put it in, whatever efficiency you have when you start, if you check it again 6 months and then after a year, it's deteriorated. That doesn't happen with a SIMSITE composite. With a structural composite, it stays the same performance. The head capacity curve doesn't deteriorate. It doesn't drop. You have a longer life, you have better reliability, and energy savings. Energy savings is huge. It's a huge expense these days. Now, with the impellers, again, they eliminate all corrosion, seawater, brine, sewage, wastewater, chlorine, bromine, and many chemicals. Electrolysis is gone, cavitation problems are gone, performance problems are gone, and balance. Balance is a huge problem today. We see more and more problems with balance, imbalance. The lightweight, they're 85% less weight. That's huge. It's less startup load, less shaft deflection. The main thing is less shaft deflection. And they're balanced for the life of the impeller. They prevent catastrophic pump failure. They're non-sparking, non-galling. And they extend the life. If you put the SIMSITE Impellers rings in a metallic pump casing, you extend the life of the metallic pump casing because you don't have this electrolysis. It's inert. And because you don't have the cavitation problems and recirculation problems that you have with the original equipment. And it eliminates the repair and maintenance expenses. And again, it doesn't deteriorate like metallic units. So I have this case study. This particular impeller came back to us 55 years. After 55 years, they sent it back. For overhaul. It's running as a main seawater circulation pump on board Pacific Tracker. This is a main circular. It was designed for 14,000 gallons per minute. Again, look at the life on it. You look at the impeller. It's almost perfect. It's unbelievable. And that's after 55 years of saltwater service. Yes, it's not stainless steel. It's not duplex. It's not super duplex. It's much better. It's SIMSITE Structural Composite. It is the best. There isn't anything even close to it on the market. Now, here's one from a power generation station. This was from the Morgantown generating station. We put this is a complete SIMSITE vertical turbine pump. It's 30 feet long. It's about 1 meter in diameter. I know it's hard to tell from the picture size here, but this is a big pump. It was operating 23 years in service. They sent it back for overhaul. Look at the inside of it. Hardly anything. If you had a metallic pump, we replaced stainless steel. The stainless steel pumps, they're 316 stainless steel pumps. They were getting about a year and a half out of them. They got 23 years out of this pump. Unbelievable. And we put in half dozen of these pumps. Here's a couple testimonials I threw in here just to show. It's one thing to say, it's another thing when other people say it. Paul Morgan when he was over at P&O Ferries, and he was also the manager at B Ships. Again, he says he doesn't understand why they aren't fitted with Sims pumps right from the beginning. It's correct, right? And the other thing is, he's a big proponent of this. When you have variable speed pumps, you can fit and design the impeller specifically for the operating point, which helps and also saves money in the long run. Here's a chief engineer for Norwegian Cruise Lines. They've been using it for years, okay? All the cruise lines. Is Clark Dodge from Washington State Ferries. He used their product for 40 years. And he's getting about 18 to 20 years, he said, out of the units. Harry Revocas from Royal Caribbean Cruise Lines when he was there. Again, he was saying how great the product is. I know these are mostly marine applications, but we also have them in power generation, wastewater, many other areas. I just threw these in here to show everybody. Again, to recap, we go back, you're eliminating all these problems, and this is what you want. You want to eliminate these problems. These are big problems, and again, if you imagine a pump that doesn't have it, you eliminate all these problems: corrosion, cavitation, casting problems, electrolysis, performance deterioration, erosion problems, clogging problems, imbalance, not operating at the best efficiency point. When you upgrade to the SIMSITE, you can operate at the best efficiency point. You not only gain efficiency and all the money that comes with it, but you gain reliability and maintenance and longevity. Lightweight, again, 85% less weight than bronze or stainless steel. Eliminate coating problems. Okay, thank you very much. If you have any questions, I'll be happy to answer them. I hope you enjoyed this video. Yeah, you have to hit the Q&A button. Okay.
We have someone in the audience raising their hand. If you want to hear from them. All right. Let's hear from Jim Morell.
Jim, how can I help you?
Hey, John. Can you hear me?
Sure.
Okay. Would you speak on recirculation between the wear ring and the impeller, certainly split case pumps, and washout problems?
Sure, that's a great topic. The area between the casing ring and the impeller wear ring is a gap. You have to have a gap. Now with composites, the gap can be much less with structural composites. With metal, you have to have a gap, or you could seize and gall, which is a problem. Now that area between there is a loss. When fluid comes through there, that's an efficiency loss. So the tighter it is, the less leakage you have, less loss. The advantage of the SIMSITE is we design with the SIMSITE casing rings and SIMSITE impellers. So we're reducing that gap. As it goes into operation, it continues to close. And it closes because composite will wear in as opposed to seizing and galling. So it's a big advantage. Now, when you put the SIMSITE casing rings in, it does a couple of different things. One is it closes that gap, which is huge. But the other thing that it does, it prevents pump washout. Now, pump washout is when the casing ring goes into the casing itself, the area under there, if it's a metallic casing, it will wear. It'll corrode, it'll wear from erosion. And that wear is a huge problem because now the casing ring becomes loose or unstable in the casing. And you have leakage and loss of efficiency through there. So the SIMSITE impeller acts like a gasket against the casing. And this gap between the impeller and the casing ring is very tight. And as you operate, it becomes a little bit tighter. And it continues to close as far as it can. It reaches a point, of course. So that is a huge advantage in terms of efficiency and in terms of saving your life for your pump casings. Did that answer your question, Jim?
Yes, thank you.
Good, thank you, appreciate it. Now we have a couple other questions here. What about the resistance, Karine? She's asking, what about the resistance to sand erosion versus other materials such as PEEK or tungsten? Sand, and if you're talking seawater, sand is very good with the structural composite. PEEK is a thermoplastic, so it will break down under pressure and temperature. But the other thing, the sand many times gets embedded in the PEEK and acts like a sandpaper. So that's not a good situation. The SIMSITE is much better again than PEEK in the sand situation. Now, tungsten is very hard. It's also very good, but it is subject to corrosion and other factors. So, but it is you can use a combination of tungsten and SIMSITE as well. JC Best, how much energy savings? Well, on the average, a SIMSITE impeller brings about a 10% increase in efficiency. And when we're talking about the whole pump, it's of course it's more. It depends on where the metallic pump is operating on in the system, but the farther away from the best efficiency point it is, the greater the savings for using a SIMSITE impeller or SIMSITE pump, because we're designing specifically. So let's say you bought a pump and it was rated at 85% efficiency, but it's operating in your system at 78. So when you upgrade, let's say you upgrade the SIMSITE to a SIMSITE impeller, we can re-engineer that impeller to operate so that we'll get not only 85, but probably get 87, 88%. If you buy a SIMSITE pump, it's designed specifically for whatever efficiency rating is. In this case, it would be probably 86, 87, 88%. So it's a huge savings. But on the average, the increase is 10%, to answer your question. Okay, Zabar is asking, what exactly is the material is used in the impeller? Further, how to protect bearings and seals in the pumps, because these are using metals. Yes, it's a very good. It's a very interesting question. Well, again, this if you're upgrading the SIMSITE impellers and rings, it's 85% less weight. So you have less shaft deflection. You have less vibration. The movement, the lower movement, enables your bearings and your seals to last much longer. In fact, sometimes what we do is we put a stabilizing bushing behind the mechanical seal. It does two things, or several things. And not only does it prevent particulate in there, but it also stabilizes the shaft. And that enables the mechanical seal to last much, much longer. We have a split version and non-split version. So the composite with the existing mechanical seals and radial bearings is a huge benefit. Okay, and our material is a structural graphite carbon fiber composite. So it's very, very strong. It has superior mechanical strength. The specific strength is huge. It's next to titanium. It's and as a result, it doesn't corrode, it's not subject to electrolysis. And it's with this 85% less weight, you have a huge benefit for all of your bearings, motor bearings, press bearings, everything is a benefit. So they last longer. We've proved over and over again that your mechanical seals will last many times longer. For example, we had a fishing vessel, and it had a split case pump. It had a huge problem with the mechanical seals. What we did is we put SIMSITE split stabilizing bushings in back of each seal in glance, and instead of getting 8 months like they were getting, they've now gotten 2 years out of the same mechanical seals. So it's a huge benefit. Also, we upgraded the impeller to SIMSITE, which was originally stainless steel. With that stainless steel, you have huge weight, huge shaft deflection. So we decreased the weight, startup load, shaft deflection, vibration. It makes a huge difference. Peter asked, can you further explain how to avoid clogging? Oh, great question. Yes. Well, to avoid clogging, what we're doing, we look at the design. So if a customer has a clogging problem, like we had many wastewater companies that had clogging problems, so we redesigned the impeller so that they wouldn't get clogged. In some cases, we went to an open impeller, so it was enclosed. We went to open. We can go both ways. We can go from open to closed or from closed to open. And with clogging, normally we're going from enclosed impellers to open, but we also open the vane passage areas up so that they're not getting the clogging that they once had. And it's been a tremendously successful program. He also asked, is it susceptible to embrittlement over time under certain conditions? Oh, another good question. No, the SIMSITE composite is not. It doesn't get brittle over time. It maintains its properties. As you can see, 55 years in service, 23 years in service. It's not, we get long life out of our unit, so it does not become brittle over time. I know there's many materials out there. Most of them are thermoplastics. Again, your plastics break down under pressure and temperature. Two things you don't want are on pumps or pressure items, such as valves. And the other problem with many thermoplastics is UV light will break them down. That's not the case with the SIMSITE structural composite. It will not break down under those temperatures. It will not get brittle. Ray Tilling. Ah, yes. I believe past testing shows that fitting SIMSITE internals results in significant noise reduction. Has this aspect been developed? Naval applications, particularly submarines. Yes, you're 100% correct, Ray. The SIMSITE is low noise and low vibration, and it gives off different signals. So it's much lower in the noise, and it's been used and been explored by some of the navies, not all the navies, but some of the navies have taken a look at this for submarine applications. I wish more of the navies would look at it because it is huge, even for propellers and other areas. But for pumps particularly, the noise is substantially reduced. Whenever we tested for noise, we were significantly lower than the metallic pumps for same pump, same operation at the same point. That's a great question, Ray. Thank you so much. Okay. Let's see. Peter asked. Okay. Okay. All right. Okay. As Zambier asked, can this be used for mud pumping? It depends on the application of mud pumping. Heavy mud pumping, no, but for if the application was, it depends on the concentration of mud to the fluid. So 15% and under, yes. But when you get over 15%, we have to stay away from it. We'd have to go to hardened metals. Okay, that's an application for hardened metals, not for structural composites or any type of softer materials. But under that, yes. For example, we use SIMSITE pumps for main intake for the Miami Aquarium, which sits in the sand silt bed. We use it on the Mississippi River, which is muddy, and they get a lot of particulate through there. We have both pumps and impellers running, and no problem on the Mississippi River. Whereas other products, including stainless and bronze and many other composites, they have problems in those areas. SIMSITE does not. Okay, let's move down. Okay, I think that's it for the questions. Any other questions? Oh, here's another one came up. Okay, Corinne, sorry. Do you have experience in oil and gas offshore environment for export line transport? We do have applications in oil and gas. Yes, we do. We are selling more and more to the oil and gas offshore environment. We came out of the marine, which is blue water vessels, and then we moved to power generation and wastewater and other areas. But the offshore is a big area. In oil and gas, we do a lot of cooling towers, especially upgrades for impellers and rings, because they always have cavitation problems, and it's eliminated with SIMS. We've gone now. We manufacture some pumps for offshore platforms off the coast of Singapore and Malaysia. We're making complete pumps with SIMSITE internals. That's solved a huge problem that they had on offshore platforms. So it's a bigger and bigger area. Okay, any other questions? I think that's it. Well, thank you very much. Appreciate the time. Thank you so much. Bye-bye now.